Apple is preparing for one of the most unusual turns in its history. After computers, smartphones, watches, headphones, and spatial computing headsets, the company is gradually moving into a completely new field: robotics. And the most interesting part is that this is no longer just a matter of rumors. Apple is officially publishing research on humanoid robots, robotic arm training, spatial perception, and machine-human interaction. At the same time, the company is hiring new engineers for its Special Projects division, which is working on robotics. In August 2026 alone, Apple posted new positions for a tactile AI research engineer and a tactile simulation research engineer for Special Projects robotics. The descriptions mention work at the intersection of mechatronics, control systems, tactile sensing, machine learning, and intelligent robotic systems. And this is precisely why the idea of an Apple humanoid robot now looks far less fantastical than it did just a few years ago. Moreover, judging by Apple's research, the company is interested in exactly the problems that are critical to humanoid robotics. In the paper, Humanoid Policy, Apple researchers study how to train a humanoid robot to perform actions based on human demonstrations. The problem with modern robotics is that collecting millions of hours of actions directly from robots is extremely difficult and expensive. Apple is therefore experimenting with a different approach. A human performs an action. The system observes it from a first-person perspective and then attempts to transfer the observed movement to a humanoid body. The researchers created the Human Action Transformer, which makes it possible to use human and robot data together. And if you think about it, this is an extremely important technology for the future of a household robot. Imagine that Apple does not need to manually program thousands of actions, such as pick up a cup, fold a shirt, clear the plate, open the refrigerator, or put groceries on the shelf. Instead, a massive collection of human actions could be used to train physical artificial intelligence. Even more interesting is another Apple study called Armor. Here, the company is focusing on the spatial perception of humanoid robots. Engineers are trying to solve a problem that sounds simple but is extraordinarily difficult in the real world: how to make a robot understand where its own arms, legs, and body are relative to surrounding objects and prevent itself from colliding with walls, furniture, or people. Apple developed a system using distributed depth sensors and tested it not only in simulation, but also on a real humanoid robot, the GR1 from Fourier Intelligence. According to Apple's published results, the system significantly reduced the number of collisions and improved movement success rates. In other words, Apple is already experimenting with real, full-sized humanoid hardware. This does not mean that the GR1 will become the foundation of a future Apple product. Quite the opposite. Today, platforms like this are primarily useful to researchers as experimental testbeds, but the fact itself is highly revealing. The company is not studying abstract robotics solely at the level of computer simulations. It is working with a real humanoid body, real sensors, real movement, and real collision avoidance. There is another extremely interesting project called Armada. Here, Apple has connected robotics with Vision Pro. A person puts on the headset, sees a virtual robot, and uses their own hands to demonstrate the required actions. The collected trajectories can then be reproduced on real robotic hardware. Apple's research essentially demonstrates one possible way in which Vision Pro and the company's future spatial devices could become tools for large-scale robot training. And this is where a much larger picture begins to emerge. Historically, Apple rarely creates products that exist completely independently of its broader ecosystem. The iPhone is connected to the Watch, AirPods, Mac, iCloud, HomeKit, and other devices. Therefore, if the company ever decides to create a full-fledged household robot, it is logical to assume that its greatest advantage would not be the mechanical hardware alone. Apple's greatest weapon would be its ecosystem. Imagine a household humanoid that understands the context of your devices. You wake up, and your Apple Watch already knows that you are out of bed. The robot receives information from the home system, opens the curtains, adjusts the temperature, brings you the item you need, while Siri simultaneously provides your schedule. When you leave the house, the robot could interact with cameras, door locks, and HomeKit. If someone calls you on FaceTime, it could follow the person around the room or transfer the call between your iPhone, television, and its own display. It could know where your Mac is, where your AirPods are, and which device is currently being used. But the most important change is that Siri, in such a scenario, would no longer simply be a voice inside your phone. It would gain a physical presence. Today, a voice assistant exists only when the user interacts with a device. A physical Siri could potentially move around the house on its own, see what is happening, and perform actions in the physical world. This could become the next fundamental stage in the evolution of artificial intelligence. The transition from AI that answers questions to AI that can actually do something, and Apple is already working on a much simpler first step in that direction. According to information from Bloomberg, which was reported by The Verge and other publications, the company has been developing a tabletop robot resembling a display mounted on a motorized arm. Such a device could turn toward a person, participate in video calls, and interact with the user through a more advanced version of Siri. Early reports said that several hundred employees were working on the company's home robotics initiative. More recent Bloomberg reporting indicated that robotics is part of Apple's broader strategy in artificial intelligence and the smart home. The company has been exploring a tabletop robot, mobile devices on wheels, and, most interestingly, has been discussing humanoid designs. At the same time, the central interface for future home devices is expected to be a significantly more conversational and visually expressive Siri. Therefore, Apple's path toward a humanoid robot is unlikely to look like Tim Cook suddenly walking onto a stage one day and unveiling a fully finished 2-meter-tall robot. Apple may move gradually. First, a smart home display. Then, a tabletop robot with a motorized arm. Then, a mobile platform capable of moving around independently. After that, more advanced manipulators could appear. And only once artificial intelligence, actuators, batteries, sensors, and robotic hands reach the necessary level could all of this potentially be integrated into a humanoid body. And in this scenario, it becomes clear why Apple is interested in this market in the first place. The company is looking for the next major computing platform. Apple's history has already included several such transitions. First, computers made computing personal. Then, the iPhone put a computer in your pocket. The Apple Watch brought computing directly onto the human body. Vision Pro is attempting to move the digital interface into the surrounding environment. And a robot could become the next logical step. A computer literally gains a body and begins interacting with the physical world. That is an enormous difference. A phone can tell you that the dishes need to be washed. A robot can wash them itself. Siri can remind an elderly person to take their medication. A physical robot could potentially bring them water and the box they need. An iPhone can show you a pizza recipe. A robot could retrieve the ingredients and help prepare it. A camera can notice an object that has fallen onto the floor. A robot could pick it up. Artificial intelligence stops being an application and becomes a physical assistant. This is precisely why such a serious race is now forming around humanoid robotics. Tesla is developing Optimus. Figure is working on its own robots. Enormous investments are flowing into American and Chinese projects. And NVIDIA is increasingly talking about what is known as physical AI. At the same time, the market is still much further away from mass adoption than the impressive demonstration videos might suggest. For example, in 2026, representatives of one major Chinese manufacturer acknowledged that modern humanoid robots still lag noticeably behind humans in efficiency for certain industrial tasks. The main challenges remain hands, reliability, speed of operation, autonomy, and the ability to work consistently well in constantly changing environments. For Apple, this is both a problem and an opportunity. The company rarely tries to be the first to bring an experimental technology to market at any cost. Its strategy is usually to wait until a technology becomes mature enough for mass consumers, and then attempt to make it as intuitive and integrated as possible. This is why Apple may not participate in the race to see whose humanoid robot can walk through a factory first. It needs a different kind of product. A household robot must be quiet, safe, attractive, relatively compact, and extremely reliable. If it is standing next to a child or a pet, the probability of an error must be extraordinarily low. If the robot picks up a glass cup, it must not crush it. If it helps an elderly person stand up, it must understand how much force to apply. If it walks past a person, it must precisely control the position of every part of its body. And this is precisely why Apple's recent job openings related to tactile artificial intelligence are so intriguing. A sense of touch could become almost as important to future robots as computer vision. A human needs only a fraction of a second to understand how firmly to squeeze a paper cup, pick up an egg, or hold a heavy pot. For a robot, these seemingly simple actions involve an enormous amount of computation, and if Apple wants to create a device for the home, capable hands and sophisticated tactile perception could prove far more important than the ability to run or jump impressively. This is where Apple could potentially apply its experience in sensors, custom chips, and compact electronics. Apple Silicon also fits perfectly into this picture. A robot would need to continuously analyze camera images, sound, a spatial map of the environment, the position of its own body, and the user's commands. Sending every movement to the cloud would be impossible because of latency and security concerns. A significant portion of the processing would have to take place directly on the device. Apple is already developing its own models designed to run on Apple Silicon, as well as its private cloud compute infrastructure for more demanding AI tasks. In theory, a future robot could perform basic perception and control locally while sending more complex requests to a secure cloud infrastructure. This is particularly important for Apple because a robot inside the home would create an entirely new level of privacy concerns. Its cameras could potentially see almost everything: documents on a desk, family members' faces, children, the interior of the house, the contents of the kitchen, and everyday habits. Its microphones would constantly be near conversations. Such a product could not be sold solely on processor specifications or the number of cameras. The buyer would have to trust the company, and Apple would almost certainly try to turn privacy into one of the robot's main competitive advantages. But why make it humanoid at all? Why not simply put a box with 2 arms on wheels? The answer lies in the world around us. Almost everything around us was designed for the human body. Door handles are positioned at human hand height. Cabinets, stairs, light switches, kitchen surfaces, washing machines, cars, and tools are all designed around our dimensions and anatomy. Therefore, a humanoid may not be the most efficient form for a robot, but it has an incredible advantage. Theoretically, it does not require us to redesign the environment around it. A human can walk into almost any apartment and understand how to open a door, turn on a light, or take a cup from a cabinet. The industry's challenge is to make a robot capable of doing the same thing. If that succeeds, the consequences could be enormous. Imagine Siri no longer living somewhere inside your iPhone. You come home, say her name, and the device on the table literally turns toward you. The screen tilts, the camera understands where you are, Siri recognizes exactly who is speaking to her, and then continues the conversation as if there were not a speaker or a tablet in front of you, but a small physical digital assistant. Just a few years ago, an idea like this would have looked like a science fiction concept. But today, Apple is gradually assembling practically all the elements needed to create such a device. The company has already officially introduced a new generation of Siri AI that can understand a user's personal context, the content displayed on the screen, information from messages, emails, and photos, work with data from the internet, and perform actions inside applications. At the same time, Apple has been researching robotics for several years and, according to Bloomberg sources, is developing a tabletop home robot with a display mounted on a movable mechanical arm. So today, we are going to examine what could become one of Apple's most unusual future products, a device that could essentially serve as a physical body for Siri. And the most interesting part is that Apple may not need to create a humanoid robot for this at all. The company may not need legs, arms, a face, or a complete body. It may be enough to make Siri capable of looking at a person, moving, hearing them, understanding the surrounding environment, and responding not only with her voice, but also through physical movement. That is when an ordinary voice assistant begins to be perceived in a completely different way. First, it is important to separate confirmed facts from information about devices that are still under development. In June 2026, Apple officially introduced Siri AI. This is no longer the old Siri, which primarily handled commands such as setting a timer or playing music. Apple says the new Siri is built around the next generation of Apple intelligence and has gained an understanding of personal context, world knowledge, the ability to work with information displayed on the screen, and deeper integration with the operating system. It can search for relevant information across the user's messages, email, photos, and other personal data, answer questions using information from the internet, and interact with applications through system-level actions. Apple has even created a dedicated app for Siri where users can return to previous conversations. All of this is extremely important in the context of a home robot, because whereas in the past putting Siri onto a moving display would not have been particularly interesting, Apple now has a much more intelligent foundation that could potentially support extended conversations and understand what is happening in a person's digital life. At the same time, the physical part of this story is beginning to emerge. According to Bloomberg, Apple is working on a family of home devices in which the new Siri is expected to play a central role. The first stage is reportedly a home hub, referred to in reports under the codename J490. It is said to feature a roughly 7-inch square display, support for video calls, facial recognition, smart home control, music playback, and Siri as its central interface. But the next project is considerably more interesting. Apple is also developing a larger display mounted on a robotic arm, and this device could represent the real transition from ordinary Siri to a physical assistant. The screen would be able to change its position in space and turn toward the user. Earlier reports about the project mentioned the ability to tilt the display up and down and rotate it by approximately 360 degrees. In other words, this is effectively not just an iPad on a stand, but a mechanical structure capable of responding to a person through movement. And this is where the most interesting part begins. Because movement itself may seem like a minor detail, what difference does it make whether the display automatically turns toward you or you simply place an iPad on a table? But Apple's own research suggests that the difference could be enormous. In January 2025, Apple researchers published a study called Elon, focused on expressive movement in non-anthropomorphic robots. For the experiments, Apple built a device resembling a desk lamp with movable segments. The researchers studied how a robot could express attention, intention, and even a certain emotional state using nothing but movement. The results showed that expressive movements noticeably increased people's engagement and strengthened the feeling that they were interacting with something more than just a mechanism. The effect was particularly strong in social interaction scenarios. In other words, Apple itself is experimentally testing the idea that a device does not necessarily need a human face to appear alive. Sometimes the way it tilts, turns, and reacts is enough. For example, imagine that Siri hears a question from someone sitting at the kitchen table. Instead of simply responding with audio, the device smoothly turns toward the person. The screen tilts slightly. The Siri interface appears facing the user. If the person moves around the room, the camera and sensors continue tracking their position, and the display follows them. If another family member joins the conversation, the device can turn toward them instead. Even without a face or eyes, the human brain automatically begins interpreting such movements as signs of attention. We constantly use similar signals in everyday life. A person turns their head when listening to someone. They lean closer when they want to show interest. They look away or change their body position. These are precisely the mechanisms Apple is attempting to transfer to robotic devices. And that is why the concept of a physical Siri is actually much deeper than it may initially appear. Apple has also researched expressive movement for more sophisticated robots. In another study published by the company Emotion, researchers used large language models to generate natural gestures and robot movements depending on the context of the interaction. The system was designed to select appropriate nonverbal responses so that the robot could communicate with people through more than just words. In some tests, the movements generated in this way were rated as comparable to, or even more understandable than, movements designed by humans. Of course, these are research projects, not confirmation that these exact algorithms will appear in a commercial Apple device. But the direction is extremely revealing. The company is simultaneously developing an intelligent Siri, robotic movement, and methods for making robots socially understandable to humans. And when these directions are combined, it becomes clear why a tabletop robot could become one of Apple's most logical next products. What is particularly interesting is that a physical Siri could potentially make use of practically the entire existing Apple ecosystem. Imagine the morning. The device recognizes the user, turns toward them, and displays a personalized interface. Siri tells you the weather, shows your upcoming appointments, reminds you about an email you wanted to send yesterday, displays the route to your first meeting, and suggests playing some music. All of this is already a natural extension of the capabilities of Siri AI, which has gained access to personal context and applications. Then, the user sits down for breakfast, and the display automatically changes its position so that it is comfortable to see. A FaceTime call begins, and the device continues keeping the person in frame. If they move to another part of the kitchen, the display can rotate to follow them. And this is where it becomes clear why Apple needs a robotic arm in the first place. It transforms the display from a stationary object into a device that can autonomously adapt to the person. The second major scenario is the smart home. Today, smart home control is distributed among phones, speakers, watches, and various control panels. Physical Siri could become a kind of central control hub for the entire home. The user says, "Make it a little cooler in here," and Siri adjusts the temperature. They ask to see who is standing at the front door, and the screen turns toward them and displays the camera feed. They ask to turn off the lights in the children's room, close the blinds, and activate the alarm system. If the device can recognize faces, it could potentially show different information to different family members. A child could see their school schedule, one adult could see their work calendar, and another could see a task list or notifications. Bloomberg has linked Apple's home strategy not only to the robot and home hub, but also to a broader focus on home security. Therefore, such a device could become the central interface connecting cameras, locks, sensors, and HomeKit into a single system. There is also a third scenario that could make the device far more important than an ordinary smart speaker. It could become a personal computer that is always nearby but does not require constant physical interaction. On an iPhone or Mac, a person has to look at the screen and interact with the interface. Physical Siri could potentially operate in a much more natural way. You could be preparing food and say, "Show me the next step of the recipe." The device turns toward you. A few minutes later, you move to another part of the kitchen, and the screen changes its angle. You say, "Add milk to the shopping list," and then continue cooking. Then you ask it to call someone on FaceTime, start a timer, and at the same time tell you when your meeting begins. None of these functions is revolutionary on its own, but when the interface is constantly physically adapting to the user, the interaction becomes less like working with a computer and more like having a conversation with an assistant. That is precisely why Apple may try to make the device's defining feature not its technical specifications, but its presence. Today, HomePod can hear you, an iPhone can see you through its camera, a Mac displays information, Apple Watch knows what is on your wrist, Vision Pro understands your gaze direction and the surrounding environment, but none of these devices physically expresses attention. A robotic Siri could become Apple's first device that literally shows, "I heard you." It turns toward you. The screen moves closer. It changes its angle. It may use Siri's animations and sound simultaneously with the movement of the body. These are small details, but they could create an entirely new type of emotional connection with technology. There is another important point. Historically, Apple has rarely been the first company to create a new category. The company did not invent the smartphone, MP3 player, tablet, smartwatch, or virtual reality headset. But Apple has repeatedly taken existing ideas and turned them into products that are easy for mainstream users to understand. The same thing could happen with home robots. Experimental home robots already exist, as do displays with automatic user tracking and smart speakers with screens. However, most of these products still feel either like gadgets for enthusiasts or like cameras mounted on stands. Apple could potentially try to transform this category into an emotionally understandable object that feels like part of the home rather than a laboratory robot. And this is where design becomes critically important. If such a device actually reaches the market, Apple will probably not make it look like an industrial robotic arm. The company will likely try to conceal the mechanical components as much as possible. Smooth aluminum, a minimal number of visible joints, rounded edges, an iPad-style display, quiet electric motors, and extremely smooth movements. Perhaps the robotic arm will move more slowly than it technically could simply so that its movements feel calm and safe. Apple's research itself shows that the speed, trajectory, and character of movement can change how people perceive a robot. The same turn can be performed abruptly and mechanically, or smoothly with a slight pause, creating an entirely different impression. The screen will probably become Siri's main visual face. Apple already uses glowing interfaces and animations to indicate when its voice assistant is active, and a physical device opens the possibility of taking this idea much further. Apple is in a very strange position today. On the one hand, it is one of the richest and most technologically powerful companies in the world, controlling the iPhone, Mac, Apple Watch, AirPods, its own processors, operating systems, and a massive ecosystem of billions of devices. On the other hand, when the real generative AI revolution began in late 2022, Apple was nowhere near the front of the pack. ChatGPT suddenly demonstrated that a computer could actually converse with a human, write code, analyze documents, explain complex topics, work with images, and maintain a long conversation. Google began aggressively developing Gemini. Microsoft integrated Copilot into its products and Azure Cloud. Meta began releasing the Llama family. Amazon started investing enormous amounts of money in AI infrastructure and its partnership with Anthropic. And against this backdrop, Siri looked as if it had become stuck somewhere in the previous decade. This is particularly surprising because Apple itself made Siri mainstream back in 2011. For millions of people, it was their first real voice assistant on a smartphone. You could set a timer, send a message, check the weather, call someone, or create a reminder. But the problem was that the old Siri and modern large language models work in fundamentally different ways. Classic Siri primarily tried to recognize a predefined command. If a person said something the system understood, it performed the action. But if the question became more complicated or the user continued the conversation, Siri often lost the context. ChatGPT demonstrated a completely different approach. A person can speak naturally, change the subject, return to previous messages, ask complex questions, and does not have to adapt every sentence to the computer. That was when it became especially obvious just how far Siri had fallen behind. It is important to understand that Apple did not miss the artificial intelligence revolution altogether. The company had been using machine learning for years in iPhone cameras, Face ID, photo processing, Apple Watch, the keyboard, speech recognition, and countless other features. Apple had even built an extremely important hardware foundation in advance, its own processors, the neural engine, and Apple Silicon, so Apple did not fall behind in machine learning itself. It fell behind specifically in large language models and generative artificial intelligence. And this is where the company's own culture played a role. Apple is accustomed to developing products internally for a very long time, carefully testing them and showing them to the public only when it considers them sufficiently mature. The AI industry works at a much faster pace. OpenAI can release a new model, improve it a few months later, and then add tools, memory, voice, images, and agents. Google does the same. Models are updated constantly. What represents cutting-edge technology today can look outdated a year later, and Apple found it difficult to adapt to that pace. Historically, Apple has often allowed other companies to enter a market first. MP3 players existed before the iPod. Smartphones existed before the iPhone. Tablets existed before the iPad. Smartwatches existed before the Apple Watch. Apple usually arrived later and made the technology more convenient for mainstream users. But AI is different from most of those previous markets. Here, timing matters enormously. The earlier a company begins training models, the faster it accumulates experience. The earlier it builds data centers, the more computing capacity it has several years later. The earlier it attracts the best researchers, the stronger its team becomes. That is why by 2024 to 2025, it had become clear that Apple really was falling behind. In 2024, the company introduced Apple Intelligence. At the presentation, the concept looked extremely powerful. Apple did not want to simply create another chatbot. It wanted to build a personal AI that understood the user's context. For example, Siri was supposed to understand who your mother was, find information about her flight in your messages or email, see events in your calendar, understand what was on the screen, and perform actions inside applications. In theory, this is even more interesting than ordinary ChatGPT, because ChatGPT may know an enormous amount of information about the world, but it does not necessarily know what email your colleague sent you this morning or when your next meeting is. Apple potentially has access to this context directly on the user's device. This is where one of Apple's main advantages lies. The company controls the iPhone. The device contains messages, photos, contacts, calendar entries, notes, email, apps, and an enormous amount of personal information. If Siri is given secure access to this information with the user's permission, it could become much more useful than an ordinary chatbot. But at the same time, this is where one of Apple's biggest problems lies: privacy. Apple has spent many years building its brand around the idea that users' personal data should remain as protected as possible. But the more AI knows about a person, the more useful it becomes. This creates a conflict. To make Siri truly personal, the system needs context, but Apple does not want to simply send all of a user's personal information to a massive cloud data center. That is why the company built the Apple Intelligence architecture around several layers. Some tasks are performed directly on the device, more complex requests are handled through private cloud compute, and in some cases, third-party models can be involved. And here Apple made a move that would have seemed almost impossible just a few years ago. The company acknowledged that it does not necessarily need to have the best general-purpose language model in the world. Apple initially integrated ChatGPT, and in 2026, it became known that Apple had entered into a multi-year collaboration with Google Gemini for a new AI architecture for Apple and Siri. At first glance, this looks almost like a defeat. Apple's main rival in the mobile operating system world is helping make Siri smarter. But if you look deeper, the strategy may be completely different. Apple may view the large language model as just one component of the overall system. The user does not necessarily need to know which model processed a particular request. An Apple model could run on the device. A more complex task could be sent to private cloud compute. Gemini could be used for some requests. ChatGPT could be used for others. And the user simply says, Siri. Apple controls the interface, the device, permissions, applications, and personal context. And this is a very important difference between Apple's strategy and OpenAI's strategy. OpenAI wants users to come to ChatGPT. Google wants users to use Gemini. Apple wants people to continue buying iPhones and remain within its ecosystem. Therefore, for Apple, the AI model itself may not be the end product. It may simply be a component. It is similar to the iPhone camera. Apple does not manufacture every single camera component itself, but users perceive the entire result as an Apple product. The same thing could happen with artificial intelligence. And this leads to the main question: why is Apple investing far less money in AI than some of its competitors? Because the scale of spending is indeed dramatically different. Google, Amazon, Microsoft, and Meta are building enormous data centers and spending tens and hundreds of billions of dollars annually on infrastructure. But it is important to understand that these expenses cannot be compared directly. Google sells Google Cloud, Microsoft sells Azure, Amazon sells AWS. Their data centers serve not only their own models, but also enormous numbers of external customers. Apple does not have a comparable cloud business. It does not need to build infrastructure for thousands of companies. Nevertheless, the gap is still enormous. Apple spends significantly less on capital AI infrastructure than the largest hyperscalers. At the same time, Apple's research and development spending is growing rapidly. During the first 9 months of fiscal 2026, the company's R&D spending reached approximately $34 billion, an increase of roughly 1/3 compared with the previous year. Apple explicitly states that part of this increase is related to investments in artificial intelligence and infrastructure. So saying that the company is saving money on AI altogether would be incorrect. It is investing a great deal. It is simply doing so in a different way. Why does Apple not want to follow the path taken by Google and Microsoft? Perhaps because the company considers the insane infrastructure race too expensive. Why should Apple build its own model capable of answering every question humanity can ask if it can use Gemini for that? Apple can focus on what truly differentiates it from its competitors. Privacy, personal context, Apple Silicon, integration with iOS, and on-device models. But this strategy carries a huge risk. Apple cannot remain dependent on Google forever. If artificial intelligence really becomes the new interface to the computer, the company that controls AI will gain enormous power over the user. That is why Apple continues to develop its own foundation models. The company already has on-device models optimized for Apple Silicon, as well as larger models for its server infrastructure. In addition, in August 2026, Reuters reported that Apple had trained a separate large language model for China with support from Alibaba. This is a very important signal. Apple is not simply going to turn Siri into a shell on top of Gemini. The company continues to develop its own technologies. Most likely, the future of Siri will be hybrid. A smaller Apple model will run directly on the iPhone. A more powerful model will operate through private cloud compute. If powerful general-purpose intelligence is needed, Gemini or another model can be used. In China, Apple's own models and Alibaba technologies may be used, and the user will never have to think about all this complexity. They will simply ask a question. That is why Apple Intelligence is better understood not as a single model, but as an entire AI system. In June 2026, Apple introduced the next generation of Siri AI. The company promises much more natural conversations, an understanding of personal context, the ability to work with on-screen content, and the ability to perform actions inside apps. In other words, Siri is gradually transforming from a voice button into a fully fledged system agent. For example, a user could say, "Find the email with my flight information, check when I arrive, and tell the person I am meeting if I am going to be late." To execute such a command, the AI must access information from multiple sources, understand the context, and perform a sequence of actions. This is precisely the next major stage of AI, not simply answering questions but actually completing tasks. And this is where Apple could suddenly gain a serious advantage. OpenAI may create a more intelligent model, but OpenAI does not have its own mobile operating system. Anthropic does not have the iPhone. Microsoft no longer has a major mobile platform. Apple, meanwhile, already controls the device on which users spend most of their day. Siri is on the iPhone. It can also work across the Mac, Apple Watch, AirPods, and other devices. If Apple can make it genuinely intelligent, it does not need to convince users to install a new service. The AI is already inside the system. This distribution is one of Apple's biggest advantages. The company has an installed base of several billion devices. Even if Siri is slightly less capable than the best version of ChatGPT, it could still be more convenient for an enormous number of everyday tasks. Samsung has spent more than 7 years investing enormous resources into creating an entirely new class of devices. It was the first company willing to take the risk of bringing a foldable smartphone to the market, endured the highly publicized problems of the earliest generations, weathered widespread criticism, repeatedly redesigned the device, completely re-engineered the hinge mechanism, invested billions of dollars in the development of flexible OLED displays, mastered their large-scale production, and gradually established itself as the undisputed leader of the foldable smartphone market. For many years, Samsung has been synonymous with this form factor. When people mentioned fold, most immediately thought of the Galaxy Z Fold. When they said flip, Samsung was once again the first brand that came to mind. The company essentially created the modern foldable smartphone market and, for years, faced no truly formidable global competitor. But that entire situation could change within a single year. Not because Samsung has suddenly forgotten how to make great smartphones, not because its technology has somehow become inferior overnight. Rather, it is because Apple may finally enter the foldable smartphone market in a meaningful way. And this is where things become especially interesting. To many people, It may seem strange to ask how a single smartphone could have such a profound impact on a corporation worth hundreds of billions of dollars. After all, Samsung manufactures televisions, home appliances, memory chips, processors, displays, batteries, camera sensors, industrial equipment, medical electronics, and countless other products. Could one foldable iPhone really pose a serious challenge to such a giant? The answer is both simple and complex. No, a single smartphone will not destroy Samsung, but it could reshape the balance of power in the most profitable segment of the mobile device market. And that could become one of the most painful blows to Samsung's mobile division in recent years. The paradox is that the biggest obstacle to the growth of the foldable smartphone market today is no longer the technology itself. Modern Galaxy Z Fold devices feature significantly more durable hinges, thinner and lighter designs, stronger construction, higher quality cameras, and have eliminated most of the problems that plagued the earliest generations. Samsung's latest foldable models consistently receive high praise for their engineering and are widely regarded as some of the finest foldable devices available. The real challenge has always been consumer psychology. For years, millions of iPhone users have watched the evolution of foldable smartphones without ever buying one. The reason was not that they disliked the form factor. Many acknowledged that the ability to transform a smartphone into a compact tablet was genuinely appealing. However, making that switch meant giving up iOS, moving to Android, transferring years of photos, learning a new operating system, replacing familiar apps, leaving Apple's ecosystem, and reorganizing their entire digital lives. For most people, that price was simply too high. As a result, Samsung found itself in a rather unusual position for many years. The company continued to improve its foldable smartphones, yet a massive portion of its potential customer base could never realistically become Samsung buyers because they were already deeply invested in Apple's ecosystem. Now imagine that this barrier disappears entirely. An iPhone user can buy a foldable smartphone without changing anything else. Every photo remains in iCloud. Every app continues to work. The Apple Watch stays connected. The MacBook continues syncing seamlessly with the phone. AirPods work just as effortlessly as before. Messages, FaceTime, and the entire Apple ecosystem remain exactly the same. The only thing that changes is the shape of the device. That moment could become a genuine turning point for the entire industry. Samsung may find itself watching millions of people, the very customers it has spent nearly 7 years trying to attract, finally decide to purchase a foldable smartphone, only to choose an iPhone instead of a Galaxy. That is the company's greatest strategic threat. And the problem for Samsung extends well beyond simply losing a portion of potential customers. What may be even more dangerous is something else entirely. Imagine Apple releases a truly outstanding foldable iPhone. Within a few months, nearly every major tech reviewer and content creator is talking about it. Every comparison revolves around the new iPhone. Headlines from the world's largest media outlets focus on Apple. In the minds of mainstream consumers, Apple becomes the company most closely associated with the new era of foldable smartphones. At that point, Samsung risks losing not only a portion of its sales, but also its psychological leadership in the category. History has shown this pattern before. Quite often, the company that pioneers a technology is not the one that ultimately makes it mainstream. In many cases, it is the second major player that transforms a niche product into a global standard. That is precisely what Samsung fears the most, especially if Apple succeeds in addressing the shortcomings that have discouraged consumers from buying foldable devices for years. Numerous reports from industry publications already suggest that Apple is placing particular emphasis on making the display crease nearly invisible and achieving exceptional build quality. At the same time, according to multiple sources, Samsung Display is expected to be the primary supplier of flexible OLED panels for Apple's first foldable iPhone. This creates one of the most unusual situations in the modern technology industry. Samsung could simultaneously emerge as both the loser and the winner. On one hand, Samsung Electronics could face an extraordinarily powerful new competitor. On the other hand, Samsung Display could generate enormous revenue by supplying displays to the biggest competitor of Samsung's own mobile business. That is why the interests of different divisions within the corporation may not be perfectly aligned. The more successful the foldable iPhone becomes, the more displays Apple will need, and the more displays Apple requires, the higher the utilization of Samsung Display's manufacturing facilities could become. From the perspective of Samsung's mobile division, however, the situation looks entirely different. Imagine the Samsung engineers who have spent nearly a decade developing foldable technology. They were the ones who solved the durability challenges of flexible displays. They were the ones who refined the hinge mechanism. They were the ones who reduced the thickness of the device. They were the ones who convinced the market that a foldable smartphone was not merely an experiment, but a practical device for everyday use. And just as the technology finally reaches maturity, Apple enters the market and captures an enormous share of public attention. The issue is not even how many iPhone Fold units Apple will sell in its first year. On the contrary, many analysts expect the first generation to be relatively expensive, with production volumes remaining limited. Looking only at sales figures, it might seem that nothing particularly significant has happened. Samsung will still be selling millions of smartphones, launching new models, maintaining a massive share of the Android market, and remaining one of the world's largest electronics manufacturers. But the real challenge could run much deeper, because in the technology industry, success is determined not only by sales, but also by brand perception. Over the past several years, Samsung has been regarded as the company setting the direction for the evolution of foldable devices. Every new Galaxy Z Fold was seen as another step forward. Even people who had no intention of buying a foldable smartphone watched Samsung's launch events because the company was showing what the mobile industry might look like several years into the future. This gave Samsung an extremely valuable advantage, the reputation of being the technological leader in this category. However, with the arrival of the iPhone Fold, the entire narrative could change almost overnight. Imagine the day Apple unveils its new device. Millions of people around the world are watching the live stream. The world's biggest media outlets publish dozens of articles. YouTube is flooded with reviews, and social media discusses every detail of the design. At that moment, the public's attention shifts. No longer is Samsung at the center of the conversation about the future of foldable smartphones. Apple is. For the average consumer, Apple becomes the symbol of a new era. Even if Samsung objectively continues to offer the more mature technology, public perception could change within just a few weeks. For any technology company, losing its status as the industry leader is not simply a matter of image. It directly affects consumer behavior. Many people buy not only a device, but also the feeling that they own the most advanced product available. That is why companies spend billions of dollars every year on launch events, advertising, and marketing. When a brand is perceived as the primary innovator, it becomes much easier to sell premium devices with high profit margins. But if public opinion begins to believe that leadership has shifted to another company, that perception gradually starts affecting financial performance as well. Another significant risk is the so-called waiting effect. Imagine a customer who has been considering buying a Galaxy Z Fold for quite some time. They have watched reviews, compared specifications, saved money, and are almost ready to make the purchase. Then news emerges that Apple's foldable iPhone is coming soon. Even if the release is still several months away, many potential buyers may decide to wait. Their reasoning is simple. If Apple is really preparing such a device, why buy a smartphone now when they will soon be able to compare both options? As a result, some of Samsung's sales may not be lost permanently, but merely postponed. However, that is still a problem for the company. Any slowdown in sales puts pressure on financial performance, especially in the premium segment, where profit margins per device are significantly higher. In addition, Samsung may find itself in a situation where it has to accelerate its development cycle. In the past, the company could steadily refine its foldable smartphones through annual updates. But once Apple enters the market, the pressure will increase dramatically. Every new Galaxy Z Fold will be compared not only with the previous Samsung model, but also with the iPhone Fold. Any shortcomings in design, battery life, performance, camera quality, or software will receive intense scrutiny. This means higher research and development costs, a greater need to introduce new technologies more quickly, and increasingly aggressive investment in innovation. Price competition will also become increasingly important. If Apple introduces a foldable smartphone at a price comparable to Samsung's flagship models, the South Korean company will have to find new ways to make its devices more appealing. This could include larger discounts, expanded trade-in programs, more attractive promotional offers, and bundles with accessories. At first glance, such measures seem beneficial for consumers, but for the company, they mean lower average profit per smartphone sold. And the premium segment has traditionally generated the highest profit margins for smartphone manufacturers. Another aspect that deserves special attention is the psychological impact on the entire Android ecosystem. For many years, Samsung has effectively been the face of the premium Android market. It was the company that demonstrated Android smartphones could compete with Apple's best devices, not only in terms of specifications, but also in innovation. However, if the foldable iPhone becomes the new must-have device for millions of users, a significant share of the attention will inevitably shift toward Apple. Imagine the year 1983. The first Macintosh is still months away. The internet as we know it today essentially does not exist. The personal computer still looks like a strange and expensive machine for enthusiasts to most people, and 28-year-old Steve Jobs stands before an audience in Aspen and begins talking about the future. At one point, he says something that more than 40 years later sounds almost unbelievable. Jobs recalls the books of Aristotle and says that the problem with a book is that you cannot ask Aristotle a question. He then proposes imagining a machine that could spend a person's entire lifetime collecting their thoughts, views, principles, and way of reasoning, so that decades later, another person could ask that machine, what would Aristotle have said about this? This is precisely the idea that the Steve Jobs archive officially preserves today. Jobs was essentially imagining a system capable of learning a person's intellectual context and then holding a dialogue with a user based on it. And this is a very important point, because a strange myth has emerged around Steve Jobs' attitude toward artificial intelligence. You sometimes hear the claim that Jobs was afraid of overly intelligent machines, that his philosophy somehow caused Apple to view AI with suspicion, and that this is why, decades later, Apple found itself behind OpenAI, Google, and other players. But the historical evidence points to almost the exact opposite. Jobs was not afraid of the idea of artificial intelligence itself. He was literally fascinated by the prospect of a computer that would stop being merely a tool and become an intelligent assistant to a human being. Moreover, in a 1985 interview, Jobs described the next stage of computer development in almost exactly the same terms that technology companies use to describe AI agents today. He talked about the transition from a computer as a servant to a computer as a guide or agent. Such a computer was supposed to notice patterns in its owner's behavior, understand recurring actions, observe external events, and respond independently when specified conditions were met. As an example, Jobs described a system that monitors stock prices, notices when a certain level has been reached, executes an action through a broker, and then informs its owner of the result. This was said in 1985. Replace stocks with email, calendars, ticket reservations, online stores, work documents, and smartphone applications. And you have something remarkably close to a description of a modern autonomous AI agent. But there is an even more remarkable connection between this old vision and Apple's situation today. Nearly a quarter of a century later, Jobs had the opportunity to encounter a technology that could have become the first real embodiment of this idea. In early 2010, the Siri application appeared in the App Store. It was not a modern language-based AI like the systems we think of today, but the idea was radical for its time. A person should not have to search for the right website, open dozens of different services, and perform every operation separately. They could simply tell an assistant what they wanted, and the system would attempt to accomplish the task. According to Siri co-founder Dag Kitlaus, just a few weeks after the launch, he received a call from Apple. He expected to speak with the head of the software division, but Steve Jobs himself was on the other end of the line. Kitlaus later recalled that he spent several hours with Jobs at his home discussing the future of the technology, and Apple soon acquired Siri. In 2010, Jobs publicly explained the acquisition in remarkably clear terms. Siri was not a search company, it was an AI company. Therefore, the idea that Steve Jobs was opposed to artificial intelligence simply does not fit the facts very well. Under his leadership, Apple acquired one of the most promising companies in the field of virtual AI assistants, while Jobs himself had already been talking decades earlier about a personal intelligent agent. And here begins one of the greatest technological ironies of modern Apple. The company whose founder saw the future of personal AI so early found itself years later in the position of a follower after the generative AI revolution had already begun. At the end of 2022, ChatGPT emerged, followed by an almost continuous race between OpenAI, Google, Anthropic, Meta, Microsoft, and dozens of startups. Models learn to see images, hear voices, understand video, write code, perform multi-step tasks, and independently work with external tools. Meanwhile, iPhone owners continued to have Siri, a product that historically appeared before most modern assistants, but increasingly looked like a product from the previous technological era. Siri could set a timer, play music, call someone, or open an application. But when users began talking to it as though it were a genuinely intelligent system, the difference between Siri and modern generative models became increasingly obvious. And Apple itself effectively acknowledged the scale of the problem. In 2024, the company announced Apple Intelligence and presented a completely new concept for Siri. It was supposed to understand the user's personal context, see what was happening on the screen, and perform actions inside applications. This was precisely the transition from a voice command to a personal agent. But then something happened that almost nobody expected from Apple. In March 2025, the company officially acknowledged that the key features of personalized Siri would take longer than anticipated and would be delayed. Reuters reported that features originally expected earlier were being pushed back until 2026. For Apple, this was a painful moment. The company had already used the future Siri in its marketing campaign, while the product itself was not ready. Bloomberg later reported that one of Siri's executives, Robbie Walker, described the situation in a conversation with employees as unpleasant and embarrassing, acknowledging that the technology had been shown publicly too early. Then a major restructuring of Apple's AI efforts began. Siri's management was brought into closer alignment with the software organization. Apple lost several prominent AI researchers and executives amid an intense war for talent. And in late 2025, the company appointed Amar Subramanya as its new vice president of AI, replacing John Giannandrea. The appointment was highly symbolic. Before joining Apple, Subramanya had worked at Microsoft, and before that, he had spent many years at Google, where his work included engineering related to Gemini. Then came something that would have seemed almost unimaginable just a few years earlier for a company whose reputation was built on controlling key technologies. In January 2026, Apple and Google entered into a multi-year agreement to use Gemini models for the new Siri. According to Reuters, Apple said that Google's technology would help power the next generation of Apple Intelligence, while the system would continue to use Apple's own architecture to protect user data. And this is where the central question emerges. How could a company that acquired Siri back when Steve Jobs was running Apple ultimately reach a point where it needed to rely on a model developed by one of its biggest competitors? The answer is probably much more complicated than simply saying that Apple missed the AI revolution, and the first reason is connected precisely to the philosophy Jobs left behind. Steve was indeed cautious about new technologies, but that caution was not rooted in fear of technology. It was rooted in a fear of releasing a bad product. The creator of Siri later recalled an idea he associated with Jobs. Apple was patient and did not rush into a new field until it believed it truly understood how to create something new and good. That philosophy worked extremely well for decades. Apple did not create the first MP3 player. It created the iPod. It did not create the first smartphone. It created the iPhone. It did not create the first tablet. It turned the iPad into a mass-market product. It did not create the first smartwatch, yet the Apple Watch became one of the most important products in its category. So within Apple, there was historically a belief that being first was not necessarily important. What mattered was waiting for the right moment, taking an existing technology, refining the user experience to an entirely different level, and then bringing it to a massive audience. But with artificial intelligence, this strategy encountered an unusual problem. AI is different from smartphones or watches because its advantage is not created solely by the final design of the product. It is created by computing infrastructure, models, research teams, data, the number of users, the speed of experimentation, and enormous amounts of computation. While one company waits for the perfect moment, a competitor can train several more generations of models, build new data centers, attract the best researchers, and accumulate billions of user interactions with its system. In this environment, being 2 years late can be far more dangerous than being 2 years late with the release of a smartwatch. And that is precisely why the scale of competitors' investments looks so impressive. In 2025, Tim Cook publicly indicated that Apple was prepared to increase its AI spending, including investments in infrastructure and potential acquisitions. Reuters at the time cited Google's plans to spend around $85 billion during the year for comparison, while Microsoft was moving towards spending more than $100 billion, a substantial portion of which was related to data centers. Apple has traditionally operated with a much more capital-efficient model and has also relied in part on renting external computing capacity. These figures cannot be compared directly because Microsoft and Google are simultaneously building enormous cloud businesses for external customers. But the difference in strategy is obvious. Competitors have begun turning computing for AI into virtually a separate industrial sector. Therefore, it can be said that Apple may indeed have inherited a certain degree of caution from Jobs. But calling it a fear of AI would be a mistake. It was more a cult of the product, control over the user experience, and an unwillingness to release a technology until it met Apple's internal standards. And the paradox is that this culture may have simultaneously made Apple the greatest product company of its generation while slowing its response to generative AI. There is another factor: privacy. ChatGPT only needs to understand the current conversation, but imagine an AI that wants to realize Jobs' original vision. To become your true personal agent, it would potentially need to understand your messages, emails, photos, contacts, calendar, location context, documents, and what is displayed on your screen. This is precisely the level of personalization Apple is trying to create today. But that means the AI gains access to the most sensitive layer of a person's digital life. Google and OpenAI can launch many features primarily through cloud-based models. Apple is trying to combine powerful AI with on-device processing and its private cloud compute system. This is significantly more difficult from an engineering perspective, but if successful, it could become one of the company's greatest advantages. And this is where it is interesting to return to Jobs himself. He did not speak only about the possibilities of technology. In a 1985 interview, he emphasized that ultimately, human wisdom would determine whether new tools were used productively. In other words, Jobs was not a naive technophile who believed that any automation was automatically good. He saw the enormous power of computers, but considered them tools for human beings. Perhaps this is where Apple's philosophy today genuinely resembles his ideas. The company is trying to build AI not as a separate digital character that users have to enter every time, but as an invisible intelligent layer embedded within the device.